Okay, let's see here. Oh, I still haven't graded all those. I forgot about those. Oh, now about most everybody's put in head first part 1. And go over to chapter 4 today. So since we didn't read the chapter, except for Caitlin, I guess, then we'll have to go over some of it in class. So then you have to do the problems on your own. We'll look at some of the problems too, but you guys are going to have to read outside of class, or else then you have to do all the problems on your own at home. Because I shouldn't have to read the chapter to you. The new chapter 4. Making decisions, which it's really not something new because we've already covered, but what an overview of selection structure, and we've already done some coding with it. Oops, I didn't get that. So if then else and selection structure, decision making, branching, however you want to call it. What happened is in the beginning we had like an overview, and then we drilled down as the semester goes on. There will be a whole chapter, so the next chapter will be over repetition. So that is, and then we'll do or it may be functions next. I can't remember for sure which order they're in, but they go a little deeper, and we've even talked a little bit about and logic and or logic because we talked about the truth tables. So that's what this chapter goes into a little more detail about comparisons, and they're called relational comparisons whenever it's talking about comparing one side of the equation to the other side of the equation. So let's go here and see if there's anything. Remember, this is what the two different types of flowchart segments that would be part of if your problem has an if then else or a selection structure in it, and we talked about that. So it goes over it again. And what's the one with 2 branches with something on each branch called? What? It's an if statement, but what kind? There's 2 kinds. If there's 2 parts, then it's called dual alternative. If there's only something you do on one side, then you don't even really have to have an else in a pseudocode. If there's nothing there, it would just be an if statement and then not an else, and it's called a single alternative. So these are, depending on the evaluation of, those are called the Boolean expression because there's 2 things that can happen. It can either be yes or no, or true or false, and these are the paths that you follow to do that. Do you remember anything in here that you might have had a question about, Caitlin?
I know one of the questions kept getting confused with the and or, even though it was really clear in the book.
The questions were kind of ambiguous, huh? Okay, so let me see if I can pull up any of those questions on the test. Well, let's go over this one first. This one problem here that's in here was the one, the if then else done with pseudocode, and they explain it out. Then here's the flow chart and pseudocode for the overtime payroll program. Now, this one simply is not an and or an or yet. This is just a simple if then else, but it does have functions here. So if you look, you can tell that the main program, and every time from here on out, what I was telling you in Python, we don't usually do a housekeeping. That's more old style coding, like if you were coding in COBOL or Fortran or something like that. But we can do a housekeeping. What you would want to do is you would want to have always your declarations, then whatever kind of values that you want to set or headings that you want to print out to the screen, then that would be in your housekeeping routine. And you notice it doesn't have a start and a stop here. Why not? What is that housekeeping? It doesn't have a start and a stop. Why does it have housekeeping and return here? What is that? It's, well, no, it's not a loop. The module, right? Good. Okay, that's a module. So that means I'm coming down. This is my main program. I start here at the top, and then I do my declarations. Then this is a function. So that means I'm going to branch to where that's a call to my function. And so I go to my function, I do the steps in it, and then it says return. Well, a return always returns back right below where the function was called. Okay, so you don't enter back, you wouldn't put your flow line back into here, because then you would execute that again, right? So it always has to have the name of whatever the calling function is, and then a return that returns it back. So this is like a template where every program will have these many steps. The loop, like somebody was saying, the loop, once you do housekeeping, this is our priming value that sets something to test. Because here, the very first thing in the loop, how can I tell this is a loop and not an if then else? This right here, this diamond shape. What makes it a loop? Yeah, it goes back here, and also your no branch, it's pretty standard to see it come down at the bottom. Whereas if it's an if then else, you're going to have a yes this way and a no over here, and then they're going to both meet. Okay, so like down here, this was an if then else, right? Because it's asking a question, and if the answer is yes, it's going to go here. If it's no, it's going to go here, but they still are going to meet at the same spot to go down the rest of the flow. So this is detail loop. So this is where all the code really happens. But the main control of the program, so you can write an outline, so to speak, of every program that would be like this. You would have declarations, housekeeping, test the loop, and while the loop is, the condition is true, then you would keep doing this, making a call to this, do it, return back, test the loop again. And do I still want to have another record that I'm working on, or more input that I'm working on? If yes, then I'm going to keep going. And then when I'm done, I do whatever it takes to finish the program. So there should be another little, which it is right here, another little finish. And all they're doing there is printing out overtime pay, calculations are complete, and return and stop. So you have to, the thing about structured code is that it always starts and stops in the main. You can't have something dangling over here in your flow chart where there's no end. So down here is the pseudocode, and you'll notice in the book, they always put, here's your main, and here's your little functions. Now remember, in Python, where do our functions go? At the top. Good, Zach. Because it's safer that way, as long as you put them before they're called. Like if I wanted to, which it doesn't make a lot of good sense, but if I wanted to put the housekeeping function code right above the call, I could, and it would work. But it's just easier to always take these in Python and stack them above. because the interpreter is going to ignore them until it gets to the main part of the program, and then it'll execute. So this is like an outline of every program, except that these declarations, of course, would be different depending upon the problem. So you could actually set up a little bit of code somewhere, your Python code that had declarations, just like it does in our MindTap. They'll put comments and they'll say, put your code here. Then they'll put a comment and say, put the other code here. So what you're doing is you're going to have declarations, housekeeping, a while loop, and instead of writing all the processing steps inside the loop, they put it in a separate function right here. And this is called structured programming. So then this one, the if then else is the clause is the part of the decision that holds the action when it's true. The else is if it's false. And so that's what this particular chapter really zeroes in on, even though structured was introduced in chapter 3, I think. So here's a chart of all the relational comparison operators that you can use. And these are used in every language. It's just sometimes they're denoted a little different, like in Python, not equal to. How did we do that? Remember? How do we say not equal to? Exclamation point and equal sign. But some languages you use the less than greater than together means not equal to. So it just you have to know the way that particular language that you're coding in. So when you're doing pseudocode, it doesn't matter. You can say not equal to, okay? Or you can use the exclamation point equal sign. So these are called comparison operators, because this one though, remember in Python, we call this an assignment operator. It's not called the equivalency operator unless it's a double equals, right? So this is generic for, they're just saying you have an equivalency operator, you have a greater than, a less than, greater than or equal to, less than or equal to, and not equal to. So those are all of the types of comparisons that you can do in any language, right? So here is an example. See, they're trying to compare, but what would we have to do in Python to make that a comparison? Two equal signs, good. So that is what would have to happen. So we're not going to really go, I know they did ask a test question about, I think, about these trivial expressions. They're kind of difficult to understand, so we don't spend any time on that. If you can figure out which one was the right one for the test, then don't worry about understanding that. That's kind of a different kind of logic. So here's some examples. Identical logic expressed using greater than or equal to and less than. So what it's showing you is you can sometimes do the same thing with greater than or equal to or less than. It's just the way you code it. See, if customer age is greater than or equal to 65, then do this, else do this. So if customer age, if somebody input 65, would it fall in the true or the false? If customer age was 65, would it be under the true portion or the false portion? The if portion or the else portion? If customer age is greater than or equal to 65, is it going to be discount equals 10% or is it going to be discount 0? Okay, because it says greater than or equal to. That's real important when you read a problem, is that you determine when they give you that comparison, do I need to just be greater than 65 or does the problem say greater than or equal to? And be sure you know whether it includes that value or not in the problem, because the problem's incorrect if you just said greater than, if it was saying anybody 65 or over. But you can notice here, if customer age is less than, so they flipped these. if customer age is less than 65. So that means if it's 65, it's going to be the false side, right? So it's just showing you two ways to code the same thing. And so here it is in flowchart. So you can go back and go over these. Be sure that you go back and read this and take that unit test before. I think, did I give you till next Monday? I think I probably did, because I was trying to make all the due dates always.
You just set it the 30th, but on
Canvas.
It says that it's like September or something.
It doesn't say September 30th. Okay, I'll go back and fix it, because Cengage is what you need to look at, because it'll lock you out. Okay, so all right, so looking in depth at and/or decisions, and this is what Caitlin was talking about here. These are a little tougher sometimes, and like she said, she understood it in the chapter, but then the way the question was worded was difficult, so I'll try to look back at that. Okay, these are called compound conditions. You know, you remember in your old grammar about a compound sentence was when they were joined by an and or, but they were called compound because they were two sentences pushed together. So a compound condition is the same thing. It is where two conditions have to either both be true, or if you're using an or, only one of them have to be true. How many of you remember the truth tables when you're in math or algebra about the and or logic? It was like, if you took algebra, then you had them for sure. Because it would say, and I think it goes into it. Does it show the truth table in this chapter? I can't remember, but it does. Okay, so here is something that we're going to look at. Look at, these are nested ifs. So this is saying, okay, let's look at this problem. Where was the problem? Here it is. For example, suppose you work for a cell phone company that charges customers as follows. The basic monthly service bill is $30. So that means everybody's going to be charged $30, right? Regardless. So your bill's going to be $30. An additional $20 is billed to customers who make more than 100 calls that last for a total of more than 500 minutes. Okay, so that means both of these have to be true, or just one to get billed the $20. How does that read? Both of them. So that's an and decision, which means it's going to be false if even one of them is false. That's the only way to get a true is if both of them are true. It's not that same way. So a nested if, an and expression can be constructed using a nested decision or nested if. And a series of nested if statements is also called a cascading if statement. So here we see two ifs. So this one is nested inside the yes branch. So right here, if calls made are not greater than calls, which calls is a constant, right? All of these are constants. So calls is equal to 100. So if we come down here and we say, okay, calls made is not greater than 100, then we're going to drop out and do nothing. We're just going to charge them the $30, right? But if calls made is greater than 100 and calls minutes is greater than whatever they said, what was that, 500 minutes, then you would add the $20 to their bill. But you notice that you could have calls over 100, but if your minutes are not over 500, you could drop out and get the same result as you did over here, right? Any questions? Everybody follow with nested ifs. Look how the code looks in pseudocode is more like what it will look like also in Python, except for you won't have these end ifs. But in Python, on the yes side of this one, if calls made are greater than calls, then if call minutes is greater than minutes, then customer bill equals customer bill plus premium. And premium is another constant up there that's set to $20. So then you would output. But you notice these end ifs here because you want to be sure that everything lines up. So if there was an else, it would have to be lined up here. And if on this if there was an else, it'd have to be lined up there. But these are, this one is not actually a single, yeah, these are all single alternative, because if the answer is false, they're not going to do anything, right? So these are the if, the ands. Now, let me go out to where that question is, and then we're going to do a couple of the mind tap ones that before we get to the ands, because I think there's a couple before that. So before next Monday, you need to take that test and be sure you've read through here and understand all of it so that you can ask questions. 2 ways to produce cell phone bills. Okay, this is just showing. Make sure. All right, so I'm going to X out of here and let me see where that test is. See if I can find one. Did you finally get it right, or did you just keep doing it till you got it right?
Yeah.
Yeah, that's how you're supposed to do. If you take time to do that, at least then you know what they're wanting. And that's the purpose of those tests, is that however long you want to spend, you can get 100% on every one of them because it's unlimited how many times you can take it. The purpose of that is for me to see if you're reading the chapter. Of course, I know you can go in there and just keep guessing until you get it right, but hopefully you want to learn what's in there. Okay, come on. Mind tap's being slow. Well, I may have to, I think it's looping and not coming up. So let's go exit out and try it again. Must be everybody hitting their server right now. There's that. There it is. Maybe. Okay, take test unit 4. Okay. Is this the one? This one's starting out with the and condition.
No, it's one of the like A, B, and C.
A, B, and C kind? Okay. Let's see. This was one that we just did. In an and condition, the most efficient technique is to first ask the question that, we didn't talk about this, but when you set up and conditions, because there's only one way for it to be false, then what is the best way to set it up where that it doesn't have to ask the next one? Like, since an and compound condition, both of them have to be true, right? So which one do you want, what do you want to happen with the first one? If it's possible that it's going to be false, then you don't even have to go to the next one, right? Does that make sense? So like if A and B, okay, if you're trying to see if A and B, if they're both, if they have to both be true, then if this one is already false, then you don't even, you'll drop out and you don't even have to go to this one, right? Paula? So it would be best if you know your data well enough to know which one is most often going to be false, then you would put it first. That's what it's asking you. In an and condition, the most efficient technique is to first ask the question that is least likely to be true. That's the one that you would want. Okay, so let me go here. We're not going to cover all of them, but oh, it's going to make me. So I'm going to find the one that she had trouble with. Continue. If condition A is 30% likely to be true and condition B is 10% likely to be true, then it's most efficient. Oh, well, that's that same question, right? Then it is most efficient to test condition A first. in an and decision, right? Oops. Oh, I must have not read it right. It even shows you, so you don't have to take it once, right? Okay, because it tells you what you did wrong. It won't let me go on. We'll find that question and then we'll, do you know which one it was?
No, it switches it up.
Oh, it does. It switches it up. Okay. So I should have those. Let me see.
Just a heads up, in Canvas, it says that the Unit 4 test isn't due until like a month later.
Oh, okay, I'll go in and fix that. Okay, let me see. I thought I had. Let me see if I don't. That's in the chapter. Maybe I don't. Well, if one of you guys have trouble with one of them and you don't understand it, take a screenshot of it and we'll talk about it on Monday. Okay. It's one she said was a little bit hard to understand the way it was worded. I just didn't read that one right. Okay, so let's go over then to the coding. Oh, let me change that since I need to tell me about that. Okay, that's in Unit 3. Here's Unit. Oh, are we in Unit? We're already in. Okay, so, oh yeah, I see where that is. But I did put it correctly in. Okay, I need to rearrange all of this anyway. So, because this is actually still part of Module 2 because we haven't even had our second test yet. Because our second test will just include if then else's, it won't have loops. So I need to put that Unit 4. I don't think I even have it drug into here.
Unit 4 test instead of 2 and then
It's not even in the module. So I must have it over here under assignments and not in there. I'll have to fix it. I'll get it fixed up this week. Okay, so if we go over here, and it's just y'all were smarter than I thought, so we went faster. That's what it is. Okay, so understanding if statements in Python. Everybody in MindTap want to do it together so you don't have to do it at home? Just so you understand, be sure you can do it on your own so that when we get to it. But these are always so tricky. I like to do them in class. But did you understand the head first one that we did? Okay, so as long as you understand that, that's the kind of test problems will be. They won't be as ambiguous. Although we're going to do these and then we're going to make some changes to them in PyCharm or idle and kind of play around with them when we get to loops more. Okay, so in this lab, we're going to complete a pre-written Python program for a carpenter who creates personalized house signs. The program is supposed to compute the price of any sign a customer orders based on the following facts. So the charge for all signs is a minimum of $35. So that means that's going to be a constant, right? The first 5 letters or numbers are included in the minimum charge. There is a $4 charge for each additional character. So that tells us we're going to have what kind of a statement? If statement. If the sign is made of oak, add $20. No charges added for pine. Black or white characters are included in the minimum charge. There is an additional $15 charge for gold leaf lettering. So there's several ifs, nested ifs, right? So everybody's going to get charged the minimum, which is $35. So this is similar to that problem that we were just looking at about the phone calls, right? Similar to that. So here it tells you down below instructions. Make sure this file is open, okay? You need to assign variables for the following. So first, it says right here, declare and initialize variables. So this is a comment, right? And it tells us this is where we're going to declare and initialize them. So that's the part of that structure that's right after you enter the program that we talked about, right? Our declarations. So first it says the charge for this sign. Okay, but we don't want it to be a comment. But that's what that one is. Charge for this sign is a variable for the cost of the sign assigned to 0. So it tells us to use the variable CHARGE, right? Equals 0.00. And then it says a variable for the number of characters, and we can follow. See, they're telling us exactly what to write because they do comments there. Oops, what did I do? Okay, the next one says, call it num chars for character. Number of characters, and assign 8. Assigned equals 8. Now, what's the difference in these and constants? Why am I, since it said give it 8 characters, why is that not a constant? Anybody know? We're going to use number characters in there and we're going to do something to it, right? We're going to add, subtract, we're going to multiply or divide. So it's just a variable, but they want you to know that you're going to start out with at least 8 characters. So that's why that's called initializing this variable. So you declare constants and you initialize your other variables. This one, we want to be sure it starts out at 0. So we gave it an initial value. Okay, then it says the color of the characters. And it says a variable for the color of the characters assigned to gold. So we're going to assume that the color is gold unless they input it to not be gold. So we have to say gold. That's what it told us to assign it, right? So we're initializing all these variables that can change. We haven't initialized any constants yet. We should have. I wonder why they did not do the constant. Okay, just a second. Wood type equals oak, right? Write the rest of the program using assignment statements and if statements as appropriate. The output statements are written for you. The charge for this sign is $82. So it's telling you what the first one should be without asking any input. So we're not asking any input. We're going to use these values that they've given us at this point. So we should actually up here, does it not have us use a constant? I guess it does not. Okay, here's one that I'll show you. So has anybody ran it? Anybody run it? But you can't get it to work. Okay, so let me find the one that's bigger where you all can see it. Mind tab. This one's called. Oops, I don't want to. Yeah. Okay, they did not use any constants for this first one. They just said all signs are $35. So they didn't use a constant right there because they're using it as a variable that can change. See, they're adding. And so for some reason, they declared it up here 0, which is what you do in most programming languages. Python, that's really not necessary. But they did tell us every sign is going to start out at $35. So they initialized this as part of the initialized variables section. Charge equals to 35. So they did it twice. All signs are 35. Does it tell us that output charge? Oh, that's no, right statement. Okay, so right here, we would want to put charge equals 35.00. And then if you want to know what it's doing, you can put a comment right there and say something like, every sign starts at $35. And so, oops, yeah, so that's a comment out next to that because I put a hashtag or a pound sign out next to it. So now I know what that's doing. Then it says write assignment and if statement. So those are going to go below here. Where'd my idle go? So below there, we're going to say if number of characters are greater than 5, then this is the statement that we want. Where's your syntax error? Was yours like that at all? PyCharm, and it works? Okay. So let's see what this does. Number of characters is greater than 5. If number of characters are greater than 5, what did it tell us to do up here? Over 5, $4. Okay, so then if that's true, then we would take number of characters because they're already at 8, right? So it'd say number of characters. And then you can do in Python something called plus equals, or you could say, here, let's do it this way, probably makes more sense in the beginning. Equals num characters plus $4, right? Or actually, we have to multiply it times the number over. I think so. Let me go back here. I think you have to do it number of characters minus 5 times 4. So that's why they did it that way. So it would say number of characters. So we have to put that in parentheses. Minus 5, because we know the first 5 characters are free, right? So any characters over 5 will be $4 each. There we go. Minus 5. But I also have to, if I do it this way, I have to say num characters plus, because I have to add it to the 8 that it already is, right? Now, the way you can actually do it in Python is called a shortcut operator, and it's plus equals. If you are in Python or any other language actually works like this, if you're going to add to this result, then you can say plus equals instead of saying number of characters equals number of characters plus. Okay, only I have to take that other plus sign off right here. Now, if it's not, what do I do? So I don't do anything if that's not true. So these are all single alternative ifs, right? These are all single alternative. So this one, then if it's would, oops, let me get over here. Do it this way. So now there's another comment, but I don't have to put the comments if I don't want. So now this one is going to say would type, I think is the question. Let me see if that's what this one is. If would type is the same as oak, charge is equal to charge plus $20. See, that's what that plus equals means. Charge equals charge plus $20. And it should work either way. You should be able to type it in either way. If the plus equals is confusing to you at this point, you can actually put, I got to put my marker here. You can actually put charge equals charge plus $20. It's the same as charge plus equals $20. So you see it eliminates having to repeat the variable name. That's what it does. They follow? So for instance, if charge is $8 and I have, say I have, what, 8 characters? Oh, if I have 8 characters, if it's over 5, then it's going to add this $20, right? Or no, this is wood type. This is not wood type. Okay, and so you notice that in pseudocode, we would have had an end if right here, right? But in Python, it doesn't make you do that. In Java and C++, you have a opening curly brace here. If this was one of those, you would have this, and then you would have a closing one at the bottom. It makes you put them at the bottom, and it takes the place of an end if. So in Python, these are, you can tell right off, these are single alternative. How do I know that? No else. Very good. No else. So that's how I know they're single alternative. Okay, the last one is if color is the same as gold, which in this case it is, right? Because we initialized it that way. So this one is color of letters, and if color, and then they said if we use the right variable names, then we didn't have to do the output statement, right? So what's another way of writing charge plus equals $15? If I was writing it like that, if I didn't want to do plus equals, what would it be? Pardon? Yes, put the variable twice, Joseph. So it would say charge equals charge plus $15, right? That's what that statement means. If anybody doesn't get that, you need to tell me, because there's probably somebody else. If you don't understand, there's more than one person. Remember what I said, there's no dumb questions, but young people don't like to ask questions. For some reason, I know I have had 2 that were especially like that. Okay, so this one should run. If it doesn't run in MindTap, we'll figure it out. Okay. Oh. This one didn't have any, any input statements. So that means they gave us the values instead of asking the user. So it can only run with those values. The charge for this sign is $70, so I did something wrong because it said the charge should be 82, right? So I must have left something out.
Charge for this sign is 70.
Is what? Yeah, this is wrong because it says here that the answer should be 82. Did anybody, you got 82? Okay, so what did I do wrong here? Can anybody see? Did anybody else's come out 82 when they ran it? Everybody? No? Yes? Let me see if I run the one that's in idle here. Okay, so what I do here, let's see. Number of characters minus 5 times 4, okay. You got 70 also? Okay, so let's see what we did wrong. Well, that one's right, so something I didn't do. Did I not put that charge equals? We're at right here. No, that one does. Num chars
That's what you're missing is the $4.
from this one, right?
That's not $4. That's $12.
Oh, this should be charge, shouldn't it? No? Let me see. Let me
Yeah,
go.
that should be charged. That's what you would.
Okay.
Charge. Like, should be charged. Not charged on the plus equal.
And no,
Should be
and
charged.
it should be charge right here. Okay, there we go. All right, so this is where I messed up. This should be charge because I'm not adding. So if I was writing this statement out without the plus equals, this one would say, let me do it here so that students can see. Note. Okay, so this one, instead of saying it like this, okay, where my notes going? Is this saying it? Oops, that's tiny in it. Font. Oh. So if I was writing this statement where it made more sense without the shortcut, what would it say? Say charge instead of plus equals, what do I say? Well, instead of plus equals, what if I don't use the plus equals and I want to do it where it makes more sense? I would say charge equals charge. Yeah, plus, and then I would say num chars minus 5. And I should be able to put this there also and get the same answer in which so this is the same as plus equals. So whatever makes better sense, if the plus equals shortcut you don't understand right now, then put it out like that. Because it should take it either way in MindTap. I'm going to do it. Okay. All right. So now I'll try to get, there's my $82. So now let's see if I get the run checks button to work. There we go. Anybody still having trouble with it? We get it? Joseph, is yours not working? Okay. Yours do? John, this looks like anybody know? You have a symbol for it? Oh, it's not. Everybody okay? Everybody else? You want to take it? Okay. Did that work, Joseph? Okay. Did you get Kobe? That's Kobe, right? Did you still not work? Okay, did you see? Is that, oh, it's double. Oh, you took it like, yeah. Perfect. Did you still get the same? This wood tie. Yeah. That's what it is. Well, it should be. Yes. Well, she said, oh, we did something. Okay, ready? Oh, all right. Best way to really learn it is what's happening, the troubleshooting, because then you can see things. The only thing is, especially the logic problems, that's good syntax. A lot of times it's bind tap, but the logic. Now, Catherine, yours should go, you should be able to make it work that way. It was something else. I mean, it should have worked charge equals charge plus 20 like you had it. That wasn't, I think it was that up here where you had the wrong variable up here. All right, so now we'll go to the next one. I think we have time for one more. And these are, yeah, and see the ones that we covered in the chapter already are if, else, and nested if. So these we did the ands, but we may not have done enough of them. Okay, so the summary in this one says, in this lab, you complete a pre-written Python program that computes. Oh, this is one that you will definitely do throughout your programming careers, trying to figure out which number is the largest, which is the third largest, which is the second largest. And this is a way to do it with nested ifs. But eventually, like some languages have what they call a switch statement, which Python does not. You either have to do it this way or with a loop. You can sometimes do it with a loop. Okay, so here they've already declared and initialized these variables. First number equals a negative 50, which we haven't worked with negative numbers yet, but it's still an integer. As long as it's not a fractional number, it's an integer, even if it's negative. Second number equals 53, third number equals 78. And then the instructions are, there are two variables named largest and smallest that are assigned to you for you. Use these variables to store the largest and smallest of the three integer values. You must decide what other variables you will need and initialize them if appropriate. Write the rest of the program using if statements or elif. Now that's what we haven't used yet either, but we've seen it somewhere. We did one that had an elif. That's instead of having an if and an else separate, I get tongue-tied. Then you, instead of doing that, the shortcut version is elif, and we'll see how that's coded. There are comments in the code that tell you where you should write your statements. The output statements are written for you, so you don't want to change the output statements down here at all. Execute the program. Your output should be, the largest value is 78 and the smallest value is negative 50. So this is without asking for input. This is with these numbers already initialized to these values. That's what your output should be. So it tells us that we need to assign a variable smallest and largest. So we can do largest, and we'd want to start it out with 0 in it, and the same with smallest, because those are, oh, and they have to have I didn't think we've ever. What? You got what? 50. Oh, okay. This is the large small. Let me make it where it's big enough for it. This is how much if else's you have to write. But actually, this part up here is where I went in and changed some things, so we don't want to do that. I hope I did still have the original. I think this is. So what you have to do, and this is with if else's instead of with elifs. I think I have another one. Let me see where the other version is, where I didn't change it. Because we play around with it with input so we could get it to work with a lot of different values is why that's different. I did that on this one. Yeah, here's the original. Okay, so this still doesn't have elifs in here. Thought I was going to use elifs, but I didn't there. Oh, and this one I didn't even use largest and smallest, did I? Yeah, I did. So I had to come up with some other variables. That's what that is, because each time you do an if, you've got to have a big one and a small one. So I named them, and you can name them whatever you want. But in here, oops, and here they're named big one. So the first comparison I want to do, I've got 3 numbers to compare, right? So first of all, I want to determine between the first number and the second number, which one is larger. So here's my first, and I'll put this in your code so you can see where it goes. That's appropriate. So here's where we'd write them below this code. If first number is greater than second number, because that's what they are up here. So I want to compare, you know, I know right now I can look at these 3 numbers and I know which is greater and which is smallest, but I need to write code that will work for any 3 numbers that are put in there. Okay, so I would say, first of all, if first number is greater than second number, then this is a variable that I'm using. Big one is equal to first number and small one is equal to second number. So if first number, if this is not true, then I just switch those 2, right? Use the same. So for every if statement, I need to know which one's the biggest and which one's the smallest. And I can only compare 2 at a time, right? I could say and, but I'm not going to use that yet. Does everybody understand that if else? Or are you just trying to copy it? Just trying to copy it, right? So you can make it work. Okay, so this one, if I run this one, I don't even have a, well, I could go ahead and say, in this case, to make it work, I could say big underscore 1 equals largest. And I could say small underscore 1 equals smallest. Now, I could run it right now and it'll work for the first 2 numbers. Oh, it didn't put anything in either one. If first number is greater than second number, is first number greater than second number? No, it's smaller. Else, so big one should actually be, yes. I need to switch where? Oh, I see what you're saying. Okay, I did my variables backwards. Largest equals big underscore 1 and smallest is equal to small underscore 1. So now let me run it, see if that's right. There we go. Okay, so now since I've given you this much, see if you can code the next if else. So since there's 3 numbers, what can I compare next? I'd have to say if what? You can do it more than one way. But if I found out which of first and second is larger, what would I compare? I now have them put in big one and small one, right? So now my if statement has to say if big underscore 1 is greater than third number, maybe? Would that work? What do you think? If you guys see something different, let me know. If big 1 is greater than third number, what do I need to do? And I don't need that yet. If big 1 is greater than third number, then I would need to make big 1 under, let's see, no, that means it's greater. So third number would go where? Anybody know? How'd you do it? Actually, they did it different than that. They then compared second number greater than third number. Here's where they do the big one. I'm going to leave that down there, and I'll go with this one. Okay, so here's what we're going to do next. So where's that? Let me put this down because we are going to do something like that. But first, we're going to compare second number if it's greater than third number. So I had to come up with 2 more variables, big 2, small 2, right? So now I have big 1 for the first comparison and big 2 and small 2 for the second comparison. So now I should have 4 variables, and so with the biggest in there. So now I need to compare big 1 to big 2, right? Big 1 to big 2, will that do it? Oh, we've only got 5 minutes left. I'll go ahead and put it up there. Then y'all better go through and make sure you understand it. Oops, where'd it go? Because I'm going to have you do something to this problem to change it. So next it's going to say, and let me go down, let me get rid of this. This, right? Okay, just a second, I'll put them where you can see it. Okay, so next thing it should say is if big 1 is greater than big 2, then that means you found the largest number, right? So it puts it in largest. Else, largest is big 2. And then in order to find what the very smallest one is, it'd be if small 1 is less than small 2, then smallest is equal to small 1, else smallest is equal to small 2. So first of all, it determined which is the largest between first and second number and which is the smallest. And then it determined between second and third. And then you have to determine which one's largest and smallest between the others. Yeah, just a second. Let me see if I can, because there's a red line, which means, okay. Let me run it, make sure it works. Let's see. Didn't run all the way. Mine didn't. Oh, yeah. The largest value is 78. The smallest value is -50.
All of these is one more statement. Doesn't even need less statement.
Did you do it different? Is that what you're saying? Okay.
They didn't
Didn't need all those if else's. Did it give you the checks? Okay, so let's see, find those. Okay. So now you need to, for Monday, be sure you've read through all of Unit 4 and taken the test and before class, so that if you have any questions, I know I give you till midnight Monday night, but you need to be sure if you have any questions. And then we'll finish that these, and then we're going to play around with these for a long time. We're going to do some exercises that are at the end of the chapter that I'll be giving you an assignment of one to change after we get through these in MindTap. So I want you to try these in MindTap before we do them in class. Like the next one, there's two that you should be able to do. You should be able to do the nested if, maybe not the multiple condition. So try it so that you can see if you can do any part of it. And then we're going to do some more simple if then else ones that I'm going to assign to you that may just have one nested if in it. If you're done, you're free to go. It's time to go.